Hello and welcome to this video lecture on pumping lemma for context-free languages. Now before we proceed with the problem, let us try to understand what context-free language is. Context-free languages are those languages which can be realized using context-free grammars. Otherwise, these kind of languages will not be considered as context-free. Okay. Now, pumping lemma is a theorem that proves that the given context-free language is not context-free. So let us try to understand the problem and how we can apply pumping lemma for that kind of problem statement. Now let us take one example, that is a language, okay, that is a to the power n, b to the power n, c to the power n, such that n greater than or equal to 1 over the language set, that is a, b and c. So if this particular language is given as context-free language, if we apply pumping lemma theorem on this, if it proves that it is not context-free, that means there is no context-free grammar which can be realized for this particular language. So this kind of language can only be solved using Turing machine, not using context-free grammar or not at all using push-down automata. Okay. Now let us see. Now before we proceed, we have to understand what exactly is pumping lemma theorem. Now pumping lemma theorem says that for some language A, here it is L, or we can say for some language L, if we choose a string S, okay, and for some pumping length, that is P, for some language L, for a given string S, and for some pumping length P, which can be assumed, such that cardinality of S should be greater than or equal to pumping length. Now suppose if I take a string, something like A, that is S equal to, and B, and C. And if I take pumping length as 3, okay, that means there are 3 A's, 3 B's, 3 C's, such that 1, 2, 3, 4, 5, 6, 7, 8, 9, that is cardinality of S, which is 9, is greater than or equal to 3, which is true. This is true. Okay, so this should be our assumption. Okay, after that, the taken string, we will have to split into 5 parts. And I hope you remember when we applied pumping lemma for regular languages, we split that particular string into 3 parts, x, y, z. Now here we are going to split this into 5 parts, that is u, v, x, y, z. U, v, x, y, z. Wherein we are going to pump these strings, substrings, that is v and y, with respect to I. Now, so when we split this into 5 parts, 5 substrings, and after we pump, we need to check with 2 cases. Case 1, that is V and Y should contain one type of symbol. V and Y should contain one type of symbol. That means we are supposed to split this string into 5 parts such that in those 5 parts V should contain one type of symbol, only one type of symbol, and Y should also contain only one type of symbol. So when we do this arrangement, we are going to test with 3 conditions. Condition number 1, that means the pumped string should satisfy should satisfy three conditions. So pumped string should satisfy below conditions. Below conditions. What are those conditions? Now, first one, the pumped string, okay, that is whatever you call S dash, should belong to the language. Should belong to the language. The second one, okay, that is the cardinality of V and Y should be greater than or equal to 0. And the third condition is cardinality of Vxy should be less than or equal to 3. If these three conditions are met, we say that the given context-free language is context-free. Otherwise, we say it is not context-free for particular case. And there is one more case to be tested. If this fails, what we say is case number 2, that is V or Y should contain both kind of symbols. Both in the sense it should contain all ABC. Okay? And once again, when we pump in that manner, okay, we test these three conditions. If there also it fails, then we say the given context-free language is not context-free. Otherwise, it is context-free. Now, let us apply these two cases and let us check these three constraints or conditions with respect to this given context-free language. Fine. So, the first case. Okay. And I have taken the string 3a, 3b, 3c, where pumping length is 3 and string length is 9, and such that it satisfies greater than or equal to b. Okay. Now let us first split this into uv, xyz. So I do like this: a, b, 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 c, c, c. So what I will do is I will take this as u. There is no restriction that you are supposed to take only 2 a's or 3 a's. You have liberty in choosing your u, v, x, and y and z. Okay. So a as u, this I will choose as v, and this will be my y, and sorry, this will be my x. Sorry, this will be my x. This will be my y, and this will be z. So I have split the string into 5 parts. Now, case 1. What case 1 says? V and y should contain one type of symbol. See, V also contains one type of symbol, Y also contains one type of symbol. It can be C also for Y, okay? It can be B also for B. Fine. Now, I will start pumping for I equal to 2. That is V to the power I, Y to the power I, for I equal to 2. So what the string, after pumping, what the string becomes? U, that is A, V to the power I, which is I equal to 2, that is V square, A. Okay, this is my U, this is my B now. Next, BB remains as it is. Then we have Y. Now Y becomes Y square, that is BB. This is my X, this is my Y, and Z remains as it is. This is my Z. So we have the pumped string, which is A, BB, and C, which is nothing but A to the power 4, B to the power 4, and C to the power 3. So what the theorem says, it should satisfy all the 3 conditions. And see here, the first condition itself is not satisfied. That is, it is not A to the power 4, B to the power 4, C to the power 4. It is A to the power 4, B to the power 4, C to the power 3, which doesn't belong to the language, and the condition fails. So here itself we can conclude that this is not a context-free language. So we can move further for the second condition, that is V, Y should be greater than 0, which is nothing but, what is V? 1, 2. What is Y? 1, 2. So 4 is greater than or equal to 0, this satisfies. Let us go for the second condition. This is first condition, this is first condition, this is second condition, and the third condition is v x y should be less than or equal to p. What is v x y? V is 2, x is 2, 4, y is 2, 6. So 6 is not less than or equal to 3. So condition 3. That means in the case number 1 itself, we can say that the context-free language is not context-free, but we should also test for case number 2. Let us see for case number 2. Now, case number 2 says that v or y should contain all kind of symbols. All kind of symbols. Now once again let us take the same string, that is A, B, B, C, C. Okay. Now this, let this be my U. I'll go with okay, this is my V, all kinds of symbols. Then this is my X. Okay, let us take a bigger string. Yes. So A, B, C. Now the pumping length is 4 for this case. Okay. You can also consider this string for the previous case. It holds true. So this is my U, this is my V, and this is my X, this is my Y, this is my Z. So any one, V or Y, should contain all kind of symbols. So in this case, V contains all kind of symbols. Now let us pump, that is for I equal to 2. Okay, this remains as it is, A, that is my U. This doubles, that is V square. This is V to the power I, this is Y to the power I. That is A, B. Once again A, B. And X remains as it is, Y 2 times and Z 2 times. Now see, this is not in a pattern as compared to A to the power n, B to the power n, C to the power n. This is A to the power n, B to the power n. Once again we have A here. So this itself says that this doesn't belong to the language. Now let us cross verify with second condition, that is V, Y should be greater than or equal to 0. That is, this is U, this is this is C. One more C. So this is my V. Okay, this is X, this is Y, this is Z. Now Vy, obviously it is greater than 0. Now this condition passes, this condition fails. The third condition, Vx, Y should be less than or equal to P. What is P? P is 4. Now what is V? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in both the cases, the taken string is proved as not context free. So hence the given grammar, given context free language is not, hence the given CFL is not context free. So I hope you understood the overall explanation. If at all it comes for your examination, okay, the question can be like, prove that the given language, given context-free language is not context-free using pumping lemma. This can be a question. Or sometimes they may ask you like illustrate with an example the pumping lemma theorem to prove a given context-free language is not context-free. Any kind of questions may come. I hope you understood this video lecture.